So read this carefully. Give only the major organic products, starting materials, or conditions for the following reactions. If more than one isomer is possible, make sure to clearly indicate both structures. This is a little bit different from last exam. Be sure to indicate the correct stereochemistry of the products using dashes and wedges or cis or trans where needed. Write no reaction or NR if no reaction occurs. So for the first one, we've got NH3 and an alkyl halide, and it doesn't indicate whether or not you're doing substitution or elimination, but you know that this is a substitution type example. So here, NH3 is considered a strong nucleophile from the notes in the book, so it's going to undergo SN2. And here the reason why it says one equivalent, don't let that confuse you, is remember NH3 can overalkylate, so in order to prevent having multiple products, we just want to use one equivalent of NH3. So what NH3 does is just regular SN2 and boots out the chlorine and causes an inversion of stereochemistry. The product has a positive charge, so I just showed it as a salt with the chlorine. So this is your correct answer. You didn't have to draw the Cl with it because it asks for just organic products. So if you want to just, I could just erase that, but just so everyone knows that it forms a salt with this type molecule. Then for part B, we're given this molecule with NBS, and it says give the major kinetic substitution product. So we know that kinetic product means best intermediate and worst overall product at the end. So we want to look at the radical intermediates. So I drew the resonance structures. The radicals might be a little bit hard to see. I'll make them a little bit bigger. So here I drew the radical. Well, you can't make a radical on this side because there's no hydrogens, but I drew the radical starting here first, the most stable position, because first of all, it's on the both of them would be on the allylic position, but it's in between allylic and benzylic, so that's a really good spot to be. When you show the resonance, when you show the radical resonating, it's moved to just the allylic position, so it's not both allylic and benzylic anymore, it's just allylic, where this one was both. So that way, now we know that that's the better intermediate because it's on an allylic and benzylic position as opposed to just allylic. Therefore, the kinetic product is going to have bromine adding in and terminating at this position. So you would get a mixture of products since your overall product would be chiral, so you'd get both enantiomers.